Okay, so let's start. I would like to welcome everybody to the first event in the Colloquium. I mean, it's a beautiful room. I've been really hard of the summer, so you can have these chairs and you can come down. So the actually it's very nice. It's a very highly improved conference room. I'm happy about it. It's a pleasure for me to introduce today Damon Centola. Damon is an associate professor in the Annenberg School for Communication and the School of Engineering and Applied Sciences at the University of Pennsylvania, where he's also the director of the Network Dynamics Group. Before coming to Penn, he was an assistant professor at MIT and a Robert Wood Johnson Fellow at Harvard University. More importantly, his PhD is in sociology, and so we have a sociologist in other areas of campus, which is great for everybody, so we're happy that we're connecting with him to involve him in both in sociology and the Population Studies Center. His research focuses on social networks and diffusion of information and cultural evolution with emphasis on health behaviors. He actually recently published an annual review of sociology work titled Social Networks and Health, New Developments in Diffusion, Online and Offline. Damon is a highly accomplished scholar. He has published in the top sociology journals, including AJS, Mathematical Sociology, has received many awards, including the ASA Award for Outstanding Article in Mathematical Sociology 3 times, 2006, 2009, and 2011. That's quite an accomplishment. And he also received the Goldman Prize for Outstanding Contribution to Sociological Methodology and the 2017 James Coleman Award for Outstanding Research in Rationality and Society. I think today he's going to touch on some elements of his previous book and his new book that he's working on or just finished, and his book, How Behavior Spreads, the Science of Complex Contagions, received the Harrison White Outstanding Book Award from the American Sociological Association. So it's a great pleasure for us to have him here. Please help me welcome Damon Centola.
Thanks, it's a pleasure to be here. So I was watching the seating pattern fill in, and it was pretty consistent with Thomas Schelling's prediction about how people, like the front row never gets filled in, except you violated the norm, except I was sitting there, so maybe you guys will get up and move back now. So yeah, no, it's a really honor to speak here, and I'm fascinated by what's going on in the Soc department. The work I'm going to talk about today is, it's work that I've been working on for over a decade, and it came out in this book with Princeton Press last summer, so a year ago. And then I've been working busily to get the second book out now, so it should be coming out next year. So there's going to be sort of some stuff from the book from last year and some stuff from the newer book. And basically what animates a lot of this work is this idea that I started really back in my sociology PhD, started thinking about, which is, how is it that this fundamental problem of cooperation, people engage in these behaviors that seem like completely impossible at the outset. And I was always fascinated as a grad student by Durkheim's suicide, because he really takes a behavior that we intuitively explain through psychological mechanisms, right? We talk about either mental illness or some other kind of existential crisis, and he explains it fundamentally sociologically. He says, look, the pattern of interaction in society can explain this individual behavior, so much so that he was like really struggling to figure out ways. And it's kind of a beautiful demonstration of the precursor of the methods that I've developed over the last decade, where he's trying to find out ways of holding two societies side by side and showing that holding all else constant, this small change in the nature of social integration would have direct effects, causal effects. That was what he was after, causal effects on the distribution of suicides in the population. That's an amazing claim, right? And it's why the book is a classic. And then people quibble over whether he really showed it or didn't show it. But to me, it always was kind of a lodestone and sort of a guiding star for thinking about how to do sociology. And so one of the intuitions I have here, and this is not Durkheim's view, it's like a departure theoretically from Durkheim's view, but it is methodologically really similar to what he was after, which is that when we think about collective behaviors and sort of, whether it's revolutions or, changes in people's compliance with the tax code, we tend to think of looking at something like this and trying to describe each fish individually and then trying to somehow intuit what the collective will do. And that's because that's all the data we've had is on individuals. And we've been able to sort of think about how the aggregation process works. But the question is, if you looked at each of these 20,000 fish individually, could you ever speculate? Could you ever come up with a model that would predict this? Let alone could you figure out what kinds of interventions would disrupt this kind of collective behavior or make it more coherent? And I feel like that's what we as sociologists are after. The video gets super interesting, but it's also not, at some point, not relevant to the talk. I think that's what we're after, is we're trying to figure out what kinds of structural interventions would actually change this collective behavior in a systematic way. And when I say prediction, what I really mean is being able to show that some intervention generates an outcome for a population and then being able to replicate it. Like really demonstrably getting causality off the ground. So the way that we think about collective behavior today is, of course, embedded in this notion of social networks. So when I think about the aggregation dynamics of lots of individuals interacting, I always think about kind of the structural medium through which they're interacting, which is social networks, at least from, it's one lens. There are other lenses to think about structure, obviously. And other papers I have out, like there's an AJS in 2015 that looks at Blau's notion of homophily consolidation as like the underlying structural manipulation. But here I'm going to focus on networks. And when we look at networks, we typically today pick out some key features, some key properties, because they're super complicated and they get really big and the statistics get hard. And so there are some sort of basic properties of networks that we pull out. And we say, well, there are some people who are incredibly central, they're incredibly well connected, and then there are people who are in the periphery. And the periphery tends to be more clustered, but also people are less connected. And when we think about a change process, and so Arab Spring is a great example of this, we tend to imagine there are people who are highly connected, and this is like our initial point into a population. Someone gets activated or starts to mobilize. She's highly connected. She mobilizes the people around her. And then from there, it kind of spreads from their friends to their friends, and the mobilization sort of cascades outward towards the periphery. This is a really intuitive model of social spreading, and we've used it for nearly a century to describe social change and ideas. There have been some sort of needles in this idea from like Doug McAdams' work on Freedom Summer, which doesn't quite jibe with this, but it hasn't really been a consistent picture. And so we've kind of defaulted to what I think of as like an epidemiological picture of like things spread from highly connected people outward. The thing is, today we can actually look at this process really for the first time. This is like Durkheim's dream, to be able to look at societies and like watch these processes unfold. And when we look at the data from Arab Spring, particularly Egypt, so there's a political scientist at UCLA, Zach Steinert, and he spent his entire dissertation, so like 5 years, just looking at the Egypt data and just trying to figure out if there was a contagion and what the contagion dynamic was. And what he found was that the origin point for like the growth of the movement in Egypt in particular, in the Tahrir Square protests, grew from the periphery of the network, from like less connected individuals who are all sort of interacting with each other. And then it kind of spread around the periphery of the population and really grew. And the sort of some of the central nodes were not activated yet. And it wasn't really till the end of the process that the highly connected people got involved. And so what you see here is a genuine empirical puzzle for sociology, where we've got, like, on the one hand, a really compelling intuitive theory of how these kinds of change processes work, and then data that just doesn't fit. And then, yeah. Oh, sorry. So this is showing spreading from the inside out, right? Which was the first kind of intuitive epidemiological way of thinking about spreading. And this is showing what the kind of model that we see from the Arab Spring data, which is that it kind of spread from the outside into the center, right? And so these are two like contrasting and almost contradictory ways of thinking about how social change emerges in a population. And what I want to focus on today is intuitions, is why the sort of classical approach, which doesn't seem to work well with the data, why it's so intuitive. And I really like, this is in the book Nudge by Kat Sunstein and Richard Thaler, but it actually comes from Shepard, who's a cognitive psychologist in the 90s. And it's a super clever example of bias, where he says, look at these two tables. The question is, which table's longer? When I looked at this, I thought, like everyone does, the table on the left is longer. It's probably got a length to width ratio of like 3 to 1, and maybe the table on the right is like 2 to 1 or 2.5 to 1. Well, it turns out you rotate them around to the same table. If you don't believe me, you think it's like a trick with a slide, I can give you like a mathematical proof. If you take the width of one table, make it the radius of a circle, draw the circumference, it bisects the length in both cases, right? So the ratio is the same. And cognitive perceptual psychologists explain this, like they're really thinking about the structure of the eye and the brain, and they're saying, well, look, essentially, the shading of the legs and the perspective of the tables create this illusion. The thing that I'm focused on, which is different than what Sunstein and Thaler are focused on, because they're basically saying, look, these illusions exist. How can we harness them to design, good advertising or good government policy? What I think is really interesting is these illusions persist even among researchers, scholars, people who, like, quote unquote, should know better. Which is to say, now that I've explained to you there's an illusion there, and explained to you the reason why there's an illusion, if I ask you which table is longer, which table looks longer, right? The point is that just because you have a new fact about the world, it doesn't actually change the way that you see the world. And this is what a lot of the talk is going to be about. It's going to be about this kind of way of changing our thinking and realizing that no matter how much we learn about the world, there are going to be intuitions that are there. So we just hired, as you know, Duncan Watts, and so he and I've known him since grad school, and so he was at Columbia when I was a grad student at Cornell, and I spent some time there, and so we've talked a lot over the years, and he has this notion that, like, once you know something, it becomes obvious, and this is sort of a contrasting point, which is that there are things that once you know them, they may not become obvious, right? You may still have to kind of perpetually remind yourself. And I think that a good example of that is social networks. So kind of the famous question that people ask when they're asking about these kind of spreading processes of social change is, how does the kind of pattern of connectedness in the society affect the spread of innovations, ideas, behaviors, and so forth? And of course, we have an answer. In 1973, Granovetter arrived and answered the question. He said, look, there's a difference between strong ties, our close friends and family, who we tend to know well and also tend to know each other. So it forms like triangles in a network, which is called clustering, and our weak ties, sort of casual acquaintances. These are people that we wouldn't lend a large sum of money to, we wouldn't ask to watch our kids, but nevertheless, there may be some sort of acquaintanceship relationship, and we learn new pieces of information from them. What Granovetter pointed out, and this is like the big insight, that it's such an important paper and it's such a clever paper, I think that some of the deep insights are almost lost sometimes, that the deep insight is that kind of affective relationship we have to our social networks really sort of gives us insight to the structure of our social networks, to this kind of mathematical, topological way of thinking about it. And that's a kind of a deep point he's making there, which is that you can take affect and use it to interpret topology. And what he's essentially saying is like strong ties are clustered together. They tend to look like that kind of periphery of the network, whereas weak ties tend to bridge across the network, tend to span social spaces. So if I have a connection with a weak tie, it pretty much means that they don't know any of my friends and I don't know any of their friends. And that means that person doesn't sort of hold a lot of gravity in my kind of internal sort of sense of my social network. But what Granovetter's point is, if you take a more objective stance, that person actually performs an important social function. They bridge these sort of gaps and they allow for ideas, behaviors, and information to sort of jump across a social topology. But that idea was formalized by the small world model. And what's interesting is that this literature, both of these two papers are basically on the same sort of topic, and each of them has like 50,000 papers. So it's fair to say this is a topic that a lot of people across a lot of different fields have really latched on to. And Granovetter, and this is like epidemiology, computer science, physics, political science, economics, sociology, right? It's like every field has taken this as like a guiding intuition. Of course, the field of network science more generally. And Granovetter sums up the core intuition in his original paper, which is very hard to do. Usually these ideas mutate over time, but his thinking is just so clear on the topic. He says, whatever is to be diffused can reach a larger number of people, traverse a greater social distance when passed through weak ties rather than strong. That's like a fairly clear idea. But what it does is it gives us an intuition, right? And what I want to suggest is that this intuition is actually kind of inbuilt. Like we look at that, we read that paper, and we say, yeah, that makes sense. Because if we look at these two networks and we say, well, which one's going to spread behavior faster? Well, if that person in the center of the left-hand network gets activated, they're going to spread it to everyone else. Obviously, like that's a fast-spreading network. And the one on the right, well, everyone's clustered together, so if one person becomes activated, a contagion has to kind of bounce around for all the intervening neighborhoods to get across the population. So it's slow. And what I want to suggest is that this intuition is wrong. It really works well for diseases. and it works well for certain kinds of information. But when it comes to social change, or what I call a complex contagion, it really leads us astray in the same way that our intuition with the tables leads us astray, where those networks will always look like fast and slow. But once we start to think sociologically about this, we realize that actually those intuitions are causing us to make sort of poor calculations when it comes to understanding dynamics. And it's not just theory, right? Because policymakers use these ideas to design not just websites, but they do use it to design websites, but they also use it to design like interventions in Africa to spread HIV prevention. Like people are using these ideas for real things and they're failing. And so part of the idea here is to get a grip on like why those ideas and intuitions fail. And the notion is that epidemiology works really well for some things and completely backfires for others. And when it comes to social change, peer reinforcement and the dynamics of the social context do more work than just mere contact. And so the exposure translating into diffusion thing, which works perfectly for the measles and for gossip, fails when it comes to complex contagions or really any kind of behavior that's risky or dangerous. There's a nice quote, I'm just gonna go through this quickly because it's kind of cute, but it's a nice example of how these sort of intuitions are so ingrained that even when they're right in front of us, we don't see them. So everyone knows Gladwell published this book, The Tipping Point, in 2000. A lot of us groaned when that came out. It seemed like a little too close to home and a little too journalistic. He just basically took grant editors and other people's ideas and then put funny stories on them. But I don't know if you probably know, but ASA gave him like the award for public sociology, which was like, maybe. But he has this Q&A in 2010 where he says, like, I'm convinced that ideas and behaviors, and this is like a summary of the book, I'm convinced that ideas and behaviors and new products move through a population very much like a disease does. And I love that he was so explicit. He says, this isn't a metaphor. I'm literally saying that ideas can be contagious in exactly the same way a virus is, right? And that's pulling out that obviously that left-hand network. And then in the same year, he publishes an article in The New Yorker where he says, even revolutionary actions that look spontaneous, like the demonstrations in East Germany, it's like Karl Dieter Opp's work, that led to the fall of the Berlin Wall, are at core strong ties. The primary determinant of who showed up was critical friends. The more friends you had were critical of the regime, the more likely you were to join the protest. So this is actually pulling out the right-hand network. So Gladwell's contradicting himself and he doesn't realize it. Right? He doesn't realize that these are two opposing statements that are invoking two different intuitions. So the point is, even when it's sitting right in front of you, it's not obvious that there's something different going on. So I'm going to talk today about, really I'm going to give you a little quick crash course in networks. I'm not sure where people are at with social networks, so it's like 4 slides. But it's just sort of an orientation in how I'm thinking about networks, because people use the term differently. And then I'm going to talk about like where the kind of the interesting kind of empirical puzzle is. And then this notion of simple versus complex contagions is going to be kind of our theoretical guide through the rest of this space. And where this gets really interesting is when we start to really understand these dynamics causally, we can build experiments. And this is where the methodological connection to Durkheim comes in, is that we can actually build worlds where we compare two societies side by side, doing real things. And the real things, the sort of ontological question, is something I'm going to focus on here today. How do we study real sociological behavior in a way that's like basically a field experiment, but it's a field experiment where we build the field, right? And that's the idea I want to invoke for you. And in the book, there's like an entire chapter where I just talk about, I learned a lot by reading ethnographers while I was writing the book, who do this beautiful thing. Like Mitch Denier does this thing at the end of Sidewalk where he goes at the end of the book and he has this like 50-page discussion of like his experience collecting the data and his like relationship to the subjects. And Marius Small has the same thing in his book. And I thought that was like a great way of bringing readers into your method. And I thought that, computational social science, computational sociology, this whole space is also a little bit obscure to people who don't do it. And so the chapter that talks about the experiment actually has this like, what was I thinking? Why did I do it this way as opposed to another? I got a reputation for doing health research. The reason, it's interesting to think about why I did a health experiment, partly because I was funded by Robert Wood Johnson, but also partly because epidemiology and social epidemiology worked really well as like a place where these theoretical ideas could land and be meaningful in a sort of a very quick way. And then the punchline here really comes back to an idea that the behavioral economists have done a great job with, which is that, and when we sit back as sociologists, when I was in grad school, we used to just, like, it was a game. We would read papers by economists and then just poke holes in them because economists are morons. They don't understand social dynamics. They don't understand networks. And I've come to really appreciate the whole sort of 150-year tradition of neoclassical economics, because what's happened is like they took it to its logical conclusion. And the behavioral economists, which used to be called psychology, the behavioral economists came in and started doing these experiments and really figuring out that the models didn't work. And to me, it's like that is progress in a theoretical research program, where all of a sudden the empirics can weigh in on your ideas. And the Chicago school maybe didn't buy it, but everyone else did. And so what wound up happening was that we now have a new way of thinking about doing policy because they pushed so hard on their ideas. And they came up with this notion that essentially, information is not neutral. The way it's presented is doing work. And if you give someone in the classic kind of rationality question, and I'm going to tie this back into the network stuff that I'm doing, the classic rationality question is you give someone, orange juice and grape juice, and which will they choose? And economists are like, well, it depends on what they prefer. If they prefer orange juice, they'll choose orange juice. And that is like a really, as much as like we've criticized it for generations, it's a really good starting point for trying to understand human behavior. And then what wound up happening was all of this work done by Kahneman, Tversky, and others that basically showed that you give someone a choice between orange juice and grape juice, they choose orange juice, then orange juice, grape juice, and like a bottle of gasoline, and then all of a sudden they choose grape juice. Right? And you're like, well, how did that happen? Like, no one's going to drink the gasoline, and all of a sudden they're like, well, grape juice is more attractive now. And so all of a sudden, the kind of informational context that people present makes a big difference on the behavior that people exhibit. And so that, of course, that is huge. This is what nudge is all about. And what I want to argue is that sociology could take a lesson from that approach, which is to say we've known for generations that social context matters. But I think we haven't been able to kind of put our finger on what to do with that. And I think that choice architecture gives us kind of a logic to think about social architecture as an intervention strategy where you can say, I can take the exact same people, put them in one social context, and the group will go in one direction. I can change the context in a way that seems trivial, right? Theoretically meaningless. And then all of a sudden the group will go in a different direction. And the question is, what do we do as sociologists when we see these things, and how do we translate them into policy? And I'll talk about that at the end. So just social networks, experimental sociology, and then the social design stuff. So just very quickly, this is an ego network. So Bob has friends, Madison, Shauna, Kieran, and Tavish. And the idea here is that we've done a lot of sociology, good sociology, with just this. We said, look, we can take a bunch of people, the GSS collects this kind of ego network data, and we can get a sense of people, sense of like integration and segregation, the pattern of interactions they have using this kind of data. What these data don't do is tell us about dynamics, right? And it was really, Granovetter along with Blau and Schwartz who really pushed on this and said, look, if you want to know what's going on with Bob, who's influencing Bob, it's not just Madison and Kieran and Shauna and Tavish who are going to influence him. It's the fact that they're connected to each other. So if Madison and Kieran are connected to each other, they can collude, they can coordinate in pressuring Bob. And that's an important fact when we're thinking about a social change process. And so we need to know not just who people are connected to, but who those people are connected to. And this is where once people started extending that logic, it turned into this idea of this sort of massive interconnected web. Like, well, who are they connected to? And they connect because the whole story matters. And this will matter. It seems like kind of an abstract idea, but this will be really important methodologically in terms of like what the best way of doing sociology is when we want to study collective behavior. And of course, this is the approach that I take as well, is to look at this sort of interconnected web. And of course, we use mathematical techniques from physics and applied math. And my PhD at Cornell was also as joint over in theoretical applied mechanics, which is either physics or engineering, depending who you talk to. But we were learning all of these fancy math techniques, and I try to impress upon people whenever I give this talk that these ideas are not coming from physics, right? The idea that we can look at the web of interconnections in a population dates back to Zimmel. It's over a century old. It's a fundamentally sociological idea that the pattern of connections in a society would govern the behaviors in that society. We just have new methodologies for really getting at it. And the way that this is something that Duncan did along with Steve Strogatz at Cornell, and this is like this model where they said, okay, can we formalize this notion of strong and weak ties? And this wasn't exactly what they were saying, but it's essentially what they were doing was saying, well, look, essentially this is a person, this is a tie, and if you draw a network like this, these people are all embedded in these kinds of locally clustered networks. Now, there's no strength in this model, which is going to be an important point. I'll bring that back in later. But right now, it's just like, ties, every tie is a weight of 1. And you can kind of take Granovetter's point and say, let's just ignore strength for a while and say that strength implies topology and just look at topology. So this is a locally clustered network where you have to spread through each neighborhood to get around it. And then you just introduce what are essentially weak ties, right? Leaping across the network. And then this network is this kind of crazy weak tie network. But the point is, and the whole 6 degrees of separation thing is like, if you ask how many steps it takes to get from this person to this person, well, it's, as that network gets really big, it's a lot of steps. It's in the same order as the size of the network. So if that's 100,000 people, you're talking about tens of thousands of steps, right? That's slow. Whereas here, when you've rewired the network, basically the number of steps to get from anyone to anyone else is log of the size of the network. So with 100,000 people, you're talking about 5 steps, right? Which is crazy. Yeah.
So I don't want to interrupt. I mean, you're doing a wonderfully succinct job of
that's the goal.
Lots of great ideas.
It's succinct.
I'm just wondering what you think about the fact that in the small world experiments, most of the messages never get through.
Yeah, so I wouldn't want to defend those experiments. It's an intuition. And I think what's interesting about this actually isn't I'm in the new book, I have this whole chapter about like Milgram, what he was doing and how it connects, but I don't want to defend that intuition. I think that there were some, particularly like the recent one in the science paper from 2000, I think that there were some mistakes made in the analysis that like there were like hubs in that network, right? This was like a key point that's ignored by this model, right? So I'm not worried about that. What I'm thinking about really is what's the weak tie intuition and how do we think about it in terms of the structure of networks? Yeah. Yep.
So how can you tell that's a weak tie in the second graph, given that the locations of those individuals probably are not relevant in this graph?
Oh, this is just a schematic. This isn't meant to be like a literal network. No, this is just, look, this is what's called, physicists call a toy model. This is not meant to be, like, people are not actually aligned like this, right? So maybe in this room, you could do a class experiment where you connected people this way, but it would be, again, a toy model. So the idea here, I'm teaching this paper tomorrow. I don't want to teach it again. But the basic idea is just that what this does is get the intuition of clustering off the ground and say, like, this is a really easy way of seeing that like friends are connected to friends, and this creates distance. And this is a really easy way to say when you start connecting people randomly, it just radically shortens distance. And that's it. That's all that matters about this model. Yeah. What's that? So a long tie is a tie that basically is spanning a long social distance. So if these sort of steps across the network would be, on the order of the size of the network, all of a sudden a long tie cuts that by, half or more, right? And so a long tie is basically a tie that forms a bridge across two groups that are otherwise not very close to each other, right? So the cool thing is we can actually study this dynamically without, the model is really nice analytically. You can do some really nice work with it. It's a really smart model. It's a really nice way of analyzing things. But the dynamics actually are what's most interesting about it. So this is the network we're just looking at. Everyone has neighbors, 2 on the left, 2 on the right, these sort of clustered neighborhoods of 4 that are overlapping. And like we put a couple innovators in, sort of our change agents, and then everyone else is shown in white. And the idea is there's going to be kind of a social contagion process where if someone is connected to an adopter, then they adopt. And this, what happens is exactly what you would think happens, which is that it spreads around the network, right? And it kind of cascades from neighborhood to neighborhood and then saturates the population. And so the idea is what happens when you add in these sort of long distance ties. And what happens is, the contagion hits those ties and just jumps across the network. And this is really the intuition. It's like, why do we care about this? It's because there's like a phenomenal impact on dynamics just by making these small changes to the topology. And one of the key points to emphasize is like, for a person in this network, this world and this world do not look different, right? And nevertheless, the dynamics are really different. And that's what gets us excited is we say, look, psychology simply can't explain it because the individuals had the same basic experience, but the collective is doing something different. And so it really motivates like what we're doing as sociologists. And then on the right-hand side, you have a couple of seed nodes, and within 3 steps, the entire network explodes. And this is, of course, what animates The whole notion of viral diffusion, viral marketing, fears of epidemiological outbreaks of measles, like this is the idea behind that. Is like now that everyone can get on airplanes, we've got ties going everywhere and stuff spreads like that. And of course, it's a really nice intuition. But so the take home here is that weak ties facilitate diffusion and that these random networks are better than sort of clustered networks. But the idea that I was sort of pushing on came from reading McAdam and Paulson in the 90s, which is, do you want to take a seat? Yeah. Okay. Oh, thank God you're not leaving. Okay. It's just about to get good. So the work they were doing, of course, was on Freedom Summer. And they were doing this analysis of ties. And they had this quote in this paper. This is like back to grad school. It's something that really kind of triggered me, where they say the fact that we're embedded in many relationships means that any major decision we are contemplating will likely be mediated by a significant subset of those relationships. So they were really pointing out here's the difference between seeing a behavior and knowing it's an option for me, which is like the mere contact model, versus having a sufficient number of people adopt that behavior, they convince me to adopt it too. And of course, Freedom Summer is a great example of this because it was incredibly dangerous. It was, as we all know, a number of the people were killed who went down there, and nevertheless, people kept going down. So what would motivate people? And their response is, look, people are embedded in these social networks that were reinforcing this, and strong ties were the key to this recruitment process. And so for me, this is really what motivated this fundamental distinction between a simple contagion, something like a virus or a piece of information or a piece of gossip, which you only really need to come into contact with once before you spread it, you adopt it, and so forth, versus a complex contagion. Anything that's difficult or costly, that's like, you need to be convinced about, or that you need to be sort of really energized for, because there's an emotional aspect to this too, but you need reinforcement in order to generate a contagion process. And this is the part of the slide that I think everyone here will know about. This is something when you speak to non-sociological audiences, you have to spend a lot of time with, which is, the dynamics that we're focused on. But underneath those dynamics, there are real theoretical motivations for why we think something would be complex. One reason people would require social reinforcement from multiple sources is just the need for credibility. This is like basic social proof 101, which is that, if I'm not sure about something and it's expensive or risky really in any way, having more people do it convinces me that either it's safe or that it's worthwhile or that the costs of doing it or the risks that I face when doing it are somehow justified. What's interesting is most people, I think, outside of sociology really conflate credibility and legitimacy. Legitimacy is something else, right? Legitimacy is that, I may believe it's a good idea, but I'm going to be laughed at if I do it. And so social reinforcement is doing a different kind of work here. What it's doing is convincing us that it's like an acceptable behavior, right? And in that sense, then we're basically starting to believe that it's normative to do this behavior. And then once we believe that, then we can do it too. And then complementarity is the most sort of economic of the mechanisms, which is just this kind of sheer calculation. Any complementary technology, any kind of coordination technology. So social media is kind of the 101 example of this. But of course, telephones. And my favorite example, which I'm told dates me, is fax machines. I love this example because it's like this, for those of you who remember fax machines, they were like these massive things that you had to buy and stick in your office. And why the hell would you do that? They were expensive, they were difficult, they were cumbersome. And if only one person had a fax machine, why bother, right? But the more people who got fax machines, like you actually needed a fax machine, right? The value of the thing skyrocketed. And of course, this is social media, right? Anything that people are doing is valuable because people are doing it. There's a third one, or a fourth one that's not on here, which is emotional contagion, which is as equally important, which is just that, like, if someone's excited about something, you can kind of say that's just them, they're excited about these sorts of things, and think now about like a social movement. But the more people you know who are excited about it, the more you start to believe that it's valuable, the more it starts to be legitimized, all these other mechanisms, but also the more genuinely excited you get about it, right? And that's something else entirely. And Doug McAdam touches on all this stuff kind of obliquely in his work on Freedom Summer, and this is kind of a network formalization of those ideas. So the question is, once we take this notion of complexity seriously, what does our do to our theory of diffusion and social change? So the network on the left is the same one we looked at. It's a lattice, everyone has 4 neighbors, 2 on the left, 2 on the right, they're overlapping, they're clustered, yeah. Yep. Oh, social media technologies. Anything where the value of the technology is contingent on other people. So more people who have telephones, the more you need a telephone. If only one person has a telephone, you can probably just stick with writing letters, right? So it's just really that the value of the behavior is literally dependent upon the number of other people doing it. Yeah. And the point is, these are all different kinds of mechanisms that generate the same social reinforcement dynamics. And so one of the things that becomes really interesting when you move to empirical spaces is when you want to study this kind of process, you really can think very carefully, and I think have to think very carefully about why you might see complexity or simplicity in a contagion dynamic. Is there legitimacy here? What kind of legitimacy is it? How do we understand it? What are the mechanics of it? And then that's where to sort of look when we're looking for these dynamics. Okay, so what does this do to the diffusion process? Anyone who's looked at the book knows what's going to happen next. But so basically it spreads around the network as before. Oh, I wanted to add that what I've done here is I've changed the model a little bit. So instead of people just adopting when their neighbor adopts, people need two sources of social reinforcement before they're adopted. So two neighbors have to adopt before they'll adopt. So basically we've changed it from like the first one was a simple contagion model, so now this is a complex contagion model. But as you can see, it spreads just like before. But noticeably, it actually spreads slower. So everyone's waiting for that like second source of social reinforcement before they adopt. Nevertheless, it still cascades around the lattice and then saturates the population. The question is, what's going to happen when we add these long distance ties in, these weak ties? And the big idea is, look, the diffusion of this was slower than the simple contagion. So the room for improvement is actually, much greater. So this should do something really significant in terms of improving the diffusion dynamics. That's all that happens. I can play it again for those who missed it. It goes by kind of quick. That. Basically, it starts to spread, and the contagion hits neighborhoods where ties have been rewired. And what happens is the underlying architecture of the lattice, basically the social reinforcement from neighborhood to neighborhood, has been eroded because some of these ties are now to far away people. And so what this does is it eliminates the social reinforcement necessary to carry the contagion. So to see this is like an up-close view of the lattice. Neighborhood A, two neighbors on the right, two neighbors on the left. Neighborhood B, two on the right, two on the left. And these common neighbors, let me just get through this. I think it'll be clear. Yeah. These common neighbors of A and B, they're sort of shared friends. Now, if A and A's friends adopt a new social norm or sort of trying to make a new behavior legitimate, there's enough social reinforcement they can convince B, and then B and those people can convince the next person and so forth, and the contagion spreads. So what happens in this process is essentially what I refer to as a wide bridge. There's been a lot of technical work done over the last decade on this notion of wide bridges. So basically, the notion is that a wide bridge is essentially a link across a space, which can be local or it can actually spread across. It can be like across a graph, but there's multiple reinforcing ties across a graph. So none of those ties themselves are narrow, right? The bridge itself is composed of lots of ties carrying this idea. And this is really what facilitates the spread of complex contagions. So when you rewire the network, what happens is you've destroyed the wide bridge. Now you still have links, right? You still have a tie from A to B's neighborhood. So it's not as if you've eliminated the structure of the graph. What you've done is to eliminate the width of the bridge. And now, people over here can still find out about this thing that A and A's friends are doing, but there's not enough social reinforcement to carry it to B's neighborhood. And this is essentially what happens when we think about the spread of complex contagions, is that erosion process is really detrimental. Now, when we think about this more generally, there's a ton of papers here, but when we think about this more generally, this model that I just showed you is the most conservative case for this idea. What I mean by that is once you introduce, so the anecdote I like to tell is that this paper came out in a physics journal and also in the American Journal of Sociology. This was a 4-page paper. This was a 45-page paper, right? AJS. And I think when I was first publishing this stuff, I was like, well, obviously the physics paper is going to be like the hardcore nuts and bolts of the result, and the sociology paper is going to be this like 40 pages of wrapping around a 5-page. So I was completely wrong. That the sociology paper is the better paper scientifically, because what you can do in 45 pages is entertain all of the questions that you have in your heads right now. What if you did this to the model? What if you added, affect, like real strength of ties? What if you added status differences into the model? What if you added tie heterogeneity? So some people were like massively connected social stars and some people were less connected. What if you added threshold heterogeneity? The thresholds you just showed us were like, a bunch of people with 1 and a bunch of people with 2. Obviously, thresholds empirically are distributed typically normally. And what happens then? Or what happens if thresholds, instead of being deterministic, 1 or 2, are probabilistic? So I have a likelihood of adopting with 1 or with 2. Sometimes I just feel more susceptible. Sometimes I feel, more curmudgeonly. right? And these are, this affects my likelihood of, how does that affect the overall dynamics? So what you can do in a paper that's 45 pages long is like analyze all of these different results. And the most exciting thing that came out of this for me was that as you added in all of this empirical realism to the model, the results in complex contagions, which is say the dependence on wide bridges, actually became stronger. Which is to say, that model I showed you is the weakest possible test of complex contagions. Because that model is basically a pure topology graph. So any link does all the work. And that's the best case scenario for basically weak ties, right? Any link does all the work. But once you start introducing in all this heterogeneity, actually, a lot of links aren't doing enough work, and especially the weak links. And so it just amplifies the importance of this sort of clustered network structure for spreading real behavioral contagions. Do you want to ask your question?
Yeah, so for the two graphs you showed
Yeah.
earlier, from the first graph, everyone has two neighbors.
Yeah, same.
The second one, they have actually more. So
No, everyone still has two. Yeah, there's.
actually, like, connected and you have this long.
That's the Watch-Strogatz model, but the one I use, the Maslov Snapin model. And so what that does, instead of rewiring, so the question is, when you rewire the graph, aren't you changing the degree distribution? And there's a model that a couple of physicists came up with that's super clever, that what it does is instead of rewiring ties one at a time, it rewires ties in pairs. And so it takes these two, sort of this local tie and this local tie, and then switches them across the graph, just at random. So it creates the same randomization process mathematically, but it preserves the degree distribution, so everyone still has 4 ties. It's like the cleanest possible way of testing this idea. Like you've done nothing except change this one feature of the network. So it's like a pure computational experiment, right? And then this actually winds up being useful when you move to empirical data, because you can sort of control that variation as well. Thank you for that question. Okay, so what I want to do is very quickly show you like some of the big actually there's a bunch of implications. The book spends a lot of time. There are chapters dedicated to all the things you can do with this now. But I want to show you one just as a teaser to like where this goes. So I'm going to bring us back to this graph. We have this notion of like highly connected influencers, the peripheral actor, the social star. And for the simple contagion, obviously one of the things about, so let's say this is like, these are low-end startup managers trying to get going in the tech space, and this is like a highly connected Fortune 500 manager. So the thing about the Fortune 500 manager is that she's got her sort of network ties, thousands of them out to the world, so she can discover innovations early on. So we think of that as great for diffusion. You can just like get on her radar, she becomes activated, and then she activates everyone else. Like that's a 101. And I want to say like, yeah, that works really well if it's just a piece of gossip. But what happens if it's a complex contagion? So think now about reputation effects. Think about a person who lives in that part of the social network. Like she didn't get here by ignoring all these social ties. She got there by paying attention to all those social ties, right? People who are highly connected are incredibly socially aware of what's legitimate and what's not, right? So what that means is that all of those ties are actually countervailing influences. All of the non-adopters implicitly, without saying anything, are people who are exhibiting some established behavior. And then you've got one person in the periphery of the network doing something different. That is not going to be a reason why a Fortune 500 manager will do that thing, right? She's going to wait for social confirmation, partly because of just her own reputation effect. So she's not, it's risk aversion, right? Otherwise, if it goes horribly sideways, she's accountable. But as more and more people do it, she's less accountable for that specific decision because everybody's doing it. But also just the sheer credibility of the idea. Like she wants to see that it's a good idea before she implements it. Contrast that with someone over here. These people have far fewer ties, so just a couple of reinforcing connections is actually a significant chunk of their social network, right? This is the McAdam and Paulson idea, that like people use a subset of their connections to decide what they do. And this means the network on the right is actually something that's going to be much more influential or effective for spreading new social contagions. Now, one of the questions that comes up a lot in the policy space is, yeah, sure, okay, I buy it, but what if I could take all the money I have and give it to someone at the center of the network? Wouldn't that be the best thing I can do? Wouldn't that be the most cost-effective thing I could do? And so you have, this idea of like activating the influencer. And I want to say, yeah, for the diffusion of a viral video, that intuition works beautifully. You get that person to adopt, and it just cascades from them to everybody else. And the question is like, what's the difference between a viral video and Arab Spring? And I want to say it's a pretty big difference. In fact, it's not a quantitative difference, it's a qualitative difference. These things spread differently. So if we're talking about a social movement that is going to involve some threat, physical harm, prison, potentially death, like that's a real decision. that just because someone who's sort of popular does it is not going to be enough to get you to do it. Because what the sort of the viral contagion model forgets is that these people, like this person has countervailing influences around them, but these people do too, and so do those people, and so do this book. Everyone who has not adopted is a countervailing influence for this kind of change process. This is most applicable to social norms. There's a whole, the new book has like 4 chapters just dedicated to social norms, like really unpacking it and applying it to, every kind of social change process we care about, because it's become topical. I don't know if you guys saw, I think Comey was on Stephen Colbert, and he was talking about like the culture inside the FBI, and he was like, yeah, well, it's a question of social norms. And I was like, wow, sociology. Like, we made an impact, I don't think that he knew what social norms meant, but it was like, at least it sort of gotten some, airplay. But I think that, operationalizing that in terms of like contagion dynamics is important, because social norms and changing social norms is one of the things we think about. So what happens when you have someone here and you've got a lot of countervailing influences is that they may, activate a couple people around them, but there's so much pressure back that like it can't actually get off the ground. Versus, and this is the same exact model, same exact sort of resistance distribution in the network. And so all I've changed is the location of our initial activists. And I put them in the periphery where they don't have a lot of power, they're not connected to a lot of people, but they are connected to each other. So they've got this sort of reinforcing network among their sort of peer group. And what you see is this kind of diffusion process that's much slower than the viral video. That's important. It looks different. And it kind of cascades around the periphery of the network, just like Arab Spring did, right? It grows and grows, and then there's enough sort of reinforcement in the outskirts to then affect the center, and then it cascades to the rest of the population. And so this idea that like changes come from the periphery and it's because people need social reinforcement shows up in a lot of different literatures. And this is one of the things about working in the sort of computational social science space that's interesting. It's like papers published in computer science and physics, in political science and psychology and sociology are all kind of talking about similar things. They're not using the same language. But there are like all these different results about the growth of technologies, like the spread of actual Twitter adoption and Facebook adoption, which is an offline behavior, right? It's like people influencing people in their offline networks. But then the spread of mobilization on Twitter and Facebook, which is an online behavior. And they both have these kinds of dynamics where change is growing in the periphery. And I just a quick note, there are lots of other implications. A big implication that comes out of this, which I'm not going to go into today, so I leave time for Q&A, but like for Ron Burt's theory of structural holes, which almost no audience I talk to, I start off that part, if I put that in the talk, I say, well, it's famous theory of structural holes, and everyone's like, the what now? Right, but of course, we know it's famous. But this idea that like these brokers across groups are doing the work for diffusing innovations in organizations. It's like, well, that is the theory of weak ties, right? That's essentially the broker is doing that work. That works really well for a new piece of information, but what you don't think about in that theory is Ron Burt's basically saying the incentives for the brokers become really rich and wealthy and powerful by occupying these positions. We have lots of connections because everyone knows they're a broker. And that's a good thing, because it means people come to them with their new ideas and their new connections. Everyone wants to exploit that, so it becomes kind of cumulative. But also, everyone knows the broker has an incentive to spread things, right? So if one group is adopting this sort of new program management technology, and it's difficult, like you need to coordinate with your whole team to get that off the ground, and the broker says, hey, this team is doing this great thing, we should do it over here too. They're like, well, that's your thing, man. You're the broker. You connect people, you sort of spread ideas, but is it really useful for our group? Will anyone in this group actually use it? Will we use it together? Maybe it works for that group because they're in engineering. We're a sales team. It's not relevant to us. So to spread it from engineering to sales, you actually need a wide bridge, reinforcing ties, so people in the sales group can, like multiple people in the sales group, can see people in engineering working together and sort of decide for themselves whether that's sort of a technology that's useful, and then talk amongst themselves in the adoption process and say, yeah, we'd all be willing to do that. And so wide bridges and organizations actually do this work, but wide bridges and organizations are detrimental to the broker, right? Because the advantage of being a broker is exclusivity. Is your whole power comes from the fact that no one else has these ties. And so it actually introduces kind of a tension now between the broker's advantage and the organization's benefit. So this is a kind of a new insight. Design thinking, social media, this is all stuff that I explore at the sort of second half of the book. So experimental sociology, what are the challenges, right? The big idea here is that we haven't been able to do this work not because people haven't tried. In the 70s, Mark Granovetter was like, we should be studying threshold dynamics in populations, right? I mean, He knew it at the outset, and he also admitted it was an incredibly hard methodological problem. And then, of course, after Nicholas did this great work on obesity and other stuff, but then obviously there were problems with the empirical inference from the correlation of ties to obese people to the inference that obese people were causing other people to become obese, right? We couldn't get that causality link off the ground. And in 2011, a colleague of mine from the Santa Fe Institute, he's a statistician, published a paper basically saying, look, trying to infer causality from observational data is impossible. He took like the hard line and said, I've done every technique I can think of, and it's just not possible. So it puts to us the question of like, well, if we need large populations and fixed architectures and fine-grained data on who adopted and when, and we need it to be reproducible. And this is a big thing. We've never really worried about this question. We said, if I have a perfect data set and I can really study this kind of behavior in it, then, I mean, that's great. That's a kind of a gold standard. But here's the thing. If you have 100,000 people connected in a network, and your theoretical like hypothesis is that those people are interacting with each other, then those data points are interdependent by construction, right? So if you're interested in a diffusion process across 100,000 people, how many data points do you have? You have one data point. You have a diffusion process. And so if you really want to study that, you need like multiple instances of a diffusion process, which again, coming back to Durkheim, is what he was trying to do. He was trying to hold societies side by side and say like, this is the idea, there's causality here. So just to bring you back to this intuition, and I love this video so much, that if we were to study this kind of process and say some intervention would demonstrably and predictably alter this collective behavior, then we need a new way of thinking about it. We need a way of saying, I can study this collective behavior once and again and again and again. And by the way, not just the intervention, I can study this collective behavior when I don't do the intervention. And this gives us this idea. I know Petri dishes is used in like the pejorative sometimes, but I think biology can be a good model for us in some cases, closer than physics actually, which is that, this idea that we can, also I get to use the pun creating cultures, but you basically can grow these sorts of cultural behaviors, these social dynamics in one population and show that like all things constant except for one theoretical difference, those behaviors don't emerge. And if you can do this and then replicate it, we're in a different space. Sociology is in a different space because this brings us really close to doing policy. Because we're basically saying, this is a field experiment, these are real people doing real things, that we can, in a replicated fashion, show that one structure of the population generates collective behavior and another doesn't, right? So the collective behavior I focused on was the spread of health behavior in a population. Subjects would come, they'd take an online health screening that would kind of get them excited about joining a community. And then when they joined the community, they were randomly assigned to different kind of network structures. And then I would assign them neighbors. I'd kind of give them a population of folks to interact with. I think people are kind of wrapping their heads around this. I did the study in like 2009 when, a lot of the reactions I got were like, why would anyone care about these strangers? But I think we're kind of understanding that people actually do care about strangers. We interact with strangers all the time, and particularly in these online spaces. And at the end, I'll very briefly talk about some of the policy work that really lands. It like shows the sociological imagination at work in policy. So what I built was this site, and what I think there are two really important things about it was the kind of sampling decision making. So everyone who came here because they were interested in health. I did not pay people, right? 2 minutes. What time is it?
12:52.
Oh no. Okay, maybe like 4 minutes. So anyway, the point here is that people weren't paid to come here. So they basically came because they were interested in being part of a community. And when, obviously people, informed consent, that's another topic. But I think if you're doing experiments, any kind of intervention, I'm kind of a hardliner about informed consent, just give it. And this was the idea. So the person shown in black is the person being randomized to both conditions. The 4 people are their assigned neighbors. They're sort of health buddies in that space. And the point here is that, for this person and this person, all they can see is their health buddies. So in both conditions, people have 4 health buddies. So the worlds psychologically look the same. What's different is the invisible social structure. And to me, this is like the hypothesis of sociology, that this invisible social structure will predictably affect collective behavior. And then of course, it's not just that it will affect it, it'll affect it in a specific, theoretically governed way. People choose avatars, they showed up they selected health interests. They got this, was like their health buddy network. And then that was it. So the dependent variable very quickly was this health community forum. I had to build something, and there's a whole methodological discussion about how to design something like this. But basically, it was like, this was the cost barrier. If you wanted to get into this thing, because you weren't being paid, so it had to be like a useful product, then you had to fill out this form. And so the question is, like, is that enough of a barrier to actually generate complexity and diffusion? Once people get in, they can use this form to like explore different health topics, rate it, share it with their buddies. The important thing about that space, the kind of key methodological idea, is that you couldn't find it, get to it, use it, adopt it. You couldn't do anything with it unless you were in my study, which meant I had a very clean set of data on diffusion because there was no other causal variable that could affect adoption. It was just whether or not you got messages from your health buddies in this network. So the results. I'm just going to cut to the chase here and show you the data since we're at the end of the talk. This is not a simulation. It's 128 human beings in this network, 128 human beings in that network. And this is, I kind of introduced the contagion here, which is signing up for the health forum. When people adopt, their neighbors say, hey, come adopt. And then other people hear about it and they adopt and they tell their neighbors and so on and so forth. It's just a contagion process. And the question is, which of these two topologies is going to accelerate that process most effectively? What you can see here is when someone adopts, the links light up. And this is like the perfect illustration of the weak ties, small world idea, is that when people adopt, links sort of fly all over the network. And of course, it generates like massive information contagion. Whereas when people adopt here, the information is constrained to their local neighborhood, which seems like counterproductive for a diffusion process. You don't want to constrain the spread of information. But what it actually does is generate social reinforcement in these neighborhoods. And what you see is that while information very quickly gets across the population here, adoption, actual uptake, spreads much more effectively in the clustered network. And this is it's a very exciting thing to see because it's like a sort of an exact comparison of two diffusion processes that are otherwise identical except for this one theoretical manipulation. And of course, the whole point here is replication. You can do this again and again and again and again. There's a lot of cool results. Obviously, it's significant. Stuff came out in Science. There are some funny stories about that. But I'm just going to kind of cut to the chase. I was able to also show that not only did people adopt the health behavior, but they actually stuck with it. They actually came back and used the forum more often if they got more reinforcing signals. And I just want to end with this idea before, I guess I'm not going to get to the policy stuff today, but I wanted to end with this idea that what this study really does is it connects an initial observational intuition, which is that there's something wrong with the theory of weak ties. It's not explaining the data on the spread of social change, and develops a theoretical model, like an abstract computational model. And the value of how abstract that model was that I was able to identify one single parameter that controlled the dynamics. And then you can build an online experiment to test specifically that idea with a real population of humans. And what should happen if science works properly is that these results aren't the end of the story. They should come back and we should do new observational research. And this is exactly what happened. There's a bunch of new observational findings in the last decade since this paper came out that have showed both offline and online how this process works, and then have actually helped to develop the theory further than I had initially. They've actually refined the theory by virtue of finding new things in the dynamics of complexity. So I'll stop with that. Thank you very much.
I think we have time for one question.
There you go. Eager ones here.
I have a question about how you think about the relationship between the structure of the social networks and the social structures that are very familiar to all sociologists, like the organization of the economy and capitalist society a lot of stuff, like organization of family relations, very familiar on gender language. And why I'm asking that is because I have a question about both the need of those social structures knowledge to actually feed a lot of the hypotheses that and a lot of the theoretical stuff embedded in the structure of the social network. But also because from the beginning you sort of presented a model based on moving from an individualist epidemiological society to one that's embedded. But most sociological tools would have gotten you there very quickly. The Arab Spring is not a coincidence, it's not just a function of the type of task that makes it origin into periphery, it's that those kinds of grievances wouldn't origin into periphery problems, right? So how do you think about embedding the structure of social networks with the?
Yeah, that's a great question. I think there's two answers. One has to do with just external belief. When you build a model, an experiment, you wonder what the generality is. even observational data has the problem like, of external validity, right? People sort of say real data, but it's data collected from like one time and place. It's one data point. It doesn't explain all future society or even all past society. So this question of like, how does it generalize is a question for any kind of study. And what's nice here is that all of the work done by Doug McAdam and Granovetter suggests that the factors that reinforce adoption and contagion are correlated with these clustered network structures, which means that these findings, again, like this study I ran where it eliminated all those factors, it did that to be like really careful. It's a super conservative study of whether topology alone could do it. When you build those factors back in, they just amplify the effects of these network structures. So what it means is like the external validity of this stuff is very, very strong. But I think the more interesting kind of response to your question is, well, can we tie these things together? Can we show in a kind of systematic, theoretical way? So I published a paper in Nature, which was the social origins of networks and confusion, and it was an attempt to answer that question. And so what I did is I connected Schwartz's theory of homomorphic consolidation. And I basically said, look, if we know where networks come from, and we want to use those variables, because some networks are hard to measure, hard to verify. If we're right, we should be able to use those demographic variables to infer a topology, and through that to infer a diffusion process. So it's kind of like A, B, C. But once we have that sort of nailed down, we infer just A, B, C. We look at pure demography and just use it to infer diffusion via kind of intuition or model of efforts. So that was the idea. The idea was first to demonstrate it, theoretically, but also really kind of ask the demographers, organizational scholars to like take this seriously. And in Louise's era, you guys know who she is? But she did this. So she now has this study where she has integration data. This is like an area, which is demographer. And she is showing that you can take the homomorphic consolidation into empirical data and use it to infer diffusion patterns. And she's able to replicate the model. It's amazing. And to explain some of the inconsistencies in the integration. So yes, absolutely. That's another thing that's like important to do analysis. Also, just a quick note in the book, there's a chapter 7, which deals with kind of modular implications in terms of structural dynamics organization. But the whole second half of that chapter answers your questions because it asks you, it basically says, if we can't manipulate networks directly, what kinds of organizational changes can we make? How much of these hallways or changing the networks? It would generate a change in the network structure and thereby generate a change in communication. So it's a real attempt to get it. Okay, so we run out of time.
Thank you.